End-to-end scrambling overview. In this schema, you can find everything you need to know to understand how a CA-protected transmission works. But let's break this schema into parts. First, the actual transfer stream payload is scrambled inside the MUX in a module called Scrambler. So the MUX acquires the transfer stream in the clear and outputs it scrambled. The key used in the scrambling process is called control world, and is actually changing every few seconds, as we'll see later, and is generated inside the MUX in another module called control world generator. So when the scrambled TS reaches the set-top box, the set-top box as such doesn't know what to do with it because it doesn't have the key to descramble it. It doesn't have the control word. So how do we send the control word securely to the set-top box? The answer is using the ECMs. So the control word is also sent from the control word generator to another module in the MUX called SCS, Simulcrypt Synchronizer, which is a role described in the DBB Simulcrypt standard as we saw before. And the SCS sends this control word to the CA system, specifically to part of the CA system called ECM generator. Together with the control word, the SCS also includes in that message the access criteria, which is a CA-specific information needed by the ECMG to build an ECM. So control word and access criteria are sent to the ECMG, and the ECMG generates an ECM and sends it back to the SCS. And the SCS places the ECMs into the transfer stream in a specific ECM pits that are signaled in the PMT. We will see that later. So the ECMs traveled embedded in the scrambled TS, and that's the way they reach the set-top box. So the set-top box receives the ECM and can decrypt it, but first, or before decryption, it needs to check with the smart card whether there are entitlements for that user required to access this specific service. And this is done by matching the access criteria, which is embedded in the ECM, with the access rights that are stored in the smart card. If the user has the entitlement required to access this service, the control word is sent to the scrambler, and then we can see the picture. Otherwise, we can't. But how does the smart card know which entitlements this customer has? So here is where the next part of the flow comes in, the EMMs. The EMMs are also encrypted CA-specific messages that are sent to the set-top box or the smart card to indicate which entitlements this specific user has. So the EMM would say something like a smart card ID XYZ can access a basic package, a sport package, and movie package, for instance. The EMM is sent from part of the CA system called EMM generator, EMMG. It's sent to the MUX, and the MUX places them in a specific pit, EMM pit in the output transfer stream. So both EMMs and ECMs travel embedded in the TS in a specific pits. As you can see, the CA system needs to know which entitlements every user has to create the EMMs, and that is why it requires an interface with the pay-TV operator SMS, a subscriber management system. So every time a new user is added to the pay-TV operator database, it needs to be also included in the EMMG database. Or every time a user buys a new package, a new subscription, a new premium package, for instance, that information needs to be sent from the SMS to the EMMG. So it's progressed through the whole chain up to the smart card. So now into the set-top box, as we said before. So once we have the ECMs and the EMMs, we know the entitlements of the user, and we get the ECMs. The smart card can check whether the access criteria in the ECM matches the access rights of this customer and decide whether it can descramble or not the service. If it can descramble it, the control word is sent to the descrambler, and the customer can watch the service.